Morning, everybody. Just a few minutes. We'll wait to see if anyone else turning up. Be interesting to see how the class goes today, with a number of schools around the country have started back this week or are starting back soon. So yeah, there might be some students who were coming to this who might now just be back in classroom. They might even be at school today and so not able to tune in. But that's okay, because it's still recorded, so all those students that have been returning each week will still be able to watch the recording if they were getting some value from it, so that's all right. So I'll just go through the normal boring housekeeping. I think most of the names on that list have been here before, so you'll be aware of it, but then at least it'll be on the video recording for anyone who comes in a bit later. So this week is the 6th, so we're halfway there. So we've scheduled to do 12, and this is the 6th one. It's the last of the 3 parts of algebra. So those who've been coming each week, and a lot of you have, you'll know that we've already spent 2 weeks on algebra, and this is the last bit that we need to do. It doesn't mean that's all of algebra, because what we'll do then is we'll use all of these algebraic skills in stuff that we keep doing. So we'll use algebra in equations, we'll use algebra in measurement, we'll use formulas, all those sorts of things. So it doesn't go away, we just build on it. So the general normal housekeeping stuff, the most important thing on this slide is that web address where you can get the recording if you want to come back and watch it later. There's benefits to that because you can stop it, you can pause it, you can go over things that you found tricky or listen again. The slides will be there as well, so if you want to just be able to go through the slides and not have to listen to the commentary, then that's all right as well. The part about Zoom, so most people have been finding the chat, so that's great. Just throw a little bit of a good morning in there if you haven't already, so that we know that you found it. We'll use the chat at the beginning and at the end. During the middle bit, you'll be able to message the panelists, so that's fine. So don't be worried if you can't sort of see other people chatting in there. It just means that people can chat directly to us, and the students don't necessarily get to chat with each other. There's a Q&A section as well. You may have found that, you may have used it before, and that's just where you can ask specific questions of myself or of Miss J. Miss J sort of goes through and tries to help you as we're going along, and anything that's worth covering at the end, we'll come back and do at the end. I try and leave myself a few minutes there so that we can do that. So, before I do this slide, we're going to jump into Pear Deck now. So those who've been here before know that we use an interactive called Pear Deck. In a different tab on your browser or on a second device, you're going to go to joinpd.com and type in the code that will appear any moment. It's just loading up. And we use this interactive so that you can answer questions, so that you can drag stuff around. It's just allows a bit of interaction when we're in this digital environment. So it's just launching up now. Now, when you load in, when you type in the code, this is, we think, the only place where you get to see who you are, because it'll give you like an animal as your own sort of identity whilst you're in the slides. Whoops, hold on a second. Don't want... Let's just pause a moment. Just give me one sec. So yeah, when you first go in, it'll say, oh, you're panda, or you're lemur, or you're penguin. So just make sure that you take note of that, because then through the lesson, when I say, oh, panda or owl, I see that you're a bit stuck, I'll be talking to you. So you sort of need to know who your spirit animal is for the rest of this lesson. Give me one sec there. Should be opening up. No, it did not work. Send that. Give me 1 second. What is that? Yes, I'm sure. Because what I want is not the teacher session. We'll try again. So whilst I'm loading this up, let's just use the chat. I'd love to know how things are going for you. Like, are you back at school? You've still got a couple of weeks. Seems to be changing quite often. I wouldn't be surprised if some of you don't even know yet when you're going back in. I think some states started this week, but only for some grades. And just for the one day, did you go back, Fergus, or you were back full time? One day. Good to see your friends, I suppose. See people that you haven't seen for a while. Oh, Ron's going back in a couple of weeks. Good morning, Josephine. Missed you there. Oh, absolutely. You can still come to this session. You can still go to the video that's on that website. So there's no reason just because you go back to school that you can't still come or watch this session. It just depends on if you're actually in school, then, 10 o'clock on a Thursday, you might supposed to be in English class. You probably can't skip English to come to my lesson. I'd be flattered, but you probably shouldn't do that. It's taking a little while to load. Hannah's going back on the 25th. Yes, everyone's a bit different. Oh, I'm so sorry. This is taking a little while to load. 1 second. Still coming. 9th of June. Yeah. I think mostly for year 8, they sort of are going back in the second round of stuff. Yes, student-based mode, that's what we want. Maybe they've changed the screen, Miss J. There's no big thing that comes up now that says where the code is.
I do see the code really small up in the top right corner.
Oh, I know why. Hold on. No, this is my fault. So I'll just show you the next slide while we do that. That'll load. I'm supposed to click instructor. Okay. I think my brain's a bit cold today. I'll talk to this slide and while Zoom's loading the back to that. So our general who we are, each week we give you a little insight into the teachers that are teaching you. We do that because we figure if we're in the classroom with you, we'd all be getting to know each other on some level. So this week is all about, have we always taught maths? That was a really common question I used to get. Well, apart from why do you like maths so much? But the second question was, is that all I teach? Because people sort of think, well, why would you only want to teach that? But I have taught other things in the past, business studies and also information technology. So teaching like computing and computing skills, that was my second major when I was at university. But my favorite thing to do is not necessarily just to teach those other things, but to actually work with those other subject areas on combined projects. So I've worked with lots of other different subjects at school, and we would get all our classes together and work on an actual thing. So one of my favourite ones was when I was in a high school in Canberra, and we were teaching with year 10s, and I had the visual arts students in my maths class and the visual arts class. We all got together and we used mathematical patterns to actually craft and build big perspex triangles that we built into a huge big structure, and it was really amazing. So we incorporated the sculptural aspect as well as the etching and the mathematical angles on that. So it was a lot of fun, and I'd love to do that stuff more full time, incorporate maths into other sorts of stuff rather than just keep it as pure maths. What about you, Miss J?
Yeah, I taught science for 3 years before I switched over to math. And my goodness, when I was in school, science was just my passion, and I loved it. And I wanted to help kids get really excited about it. And I feel like I did that. We did experiments almost every day, and, lit things on fire, and, made things change color. And I took a group of kids to SeaWorld camp. And I know SeaWorld can be a bit controversial, but in the background of SeaWorld, they have this huge rehabilitation center, and the camp is about educating kids on the rehabilitation and the rescue efforts that they do. So they got to interact and help the animals, and it was so much fun. But I realized I was spending so much of my time in my science classroom helping kids with math, like converting measurement units and working with exponents with astronomical units. It was just so difficult. And I really made a connection with a lot of kids and decided maybe I should switch over to math and see if I can make that a little bit more of a difference there than even getting kids excited about science, because most kids love their science teachers. That's usually the favorite.
Oh. All right, so I finally got this up. Sorry, that took a while. So remember, the website is joinpd.com. The code is there. Make sure you take note when you log in what animal you are, because then I'll be able to refer to that as we go through. So the joinpd.com, and the code is quick drums inspect hilarious olives. I don't know how an olive could be funny. So QDIHO. We don't have many in the class, so hopefully it doesn't take long for you to all jump in. Yep, so just make sure you grab which animal you are. And then when I call that animal out, you'll know it's you, but I won't be, no one else will know it's you. So it'll be a little secret. Just a few more need to connect in. Sorry, I've got an itchy nose. Just a few more. So just joinpd.com. Now, you don't have to, of course. You may just want to watch along, but it does help with the connection to the content material if you're able to engage with it. So, yep. Just a few more. Okay, so if you're on the call and you haven't got in yet, Miss Jay's happy to help you out with the code if you've got a bit lost, but hopefully you all were able to keep track of what animal you were. I'm just going to skip through to where we were. Okay, so this is our first practice interactive where we get to learn a bit about you as well. So Miss Jay and I have given you a little bit of an insight into the sorts of subjects that we like outside of maths. So I sort of liked a bit of everything, but particularly I like the arts. So if you've got a sort of favourite subject that's not mathematics, because obviously we all love maths, just drag the little icon into one of those. If the thing that you really love isn't there, you can probably just leave your dot outside the screen, or you could just choose from those 5, which is the most favourite area. So just drag your icon in, and then we'll show the responses. There we are. Now we can see the responses. Just move your little icons over a little bit. Oh, it's a really good blend. That's fantastic. Yeah, nice one. No one likes the arts. Oh, I'm so surprised. I'm a little tidbit too. I'm actually a classical pianist, so I play the piano classically. I've been in an orchestra and in a couple of bands as well. So that's that art bent I've got. Okay, just going to lock the screen in 3, 2, 1. Nice one. Yeah, that's great. It's good to know a little bit about everybody and sort of who the sorts of interests that we have in the room. So that's our interaction. That's just our little practice one, and we'll have heaps more of those sorts of things as we move through. So where are we in our learning? As you know, last week we were doing expanding and we did a little bit of substitution. So expanding the brackets, remember that was sort of multiplying out through the brackets, and we used the rectangle method for that. This week we're going to do factorizing, which is kind of like the opposite. It's like putting it into brackets. So we'll do that. And at the end, if we've got time, we'll just hit those key points about all of the whole algebra chapter. And then next week we start equations. where you'll see that word algebra again, we're going to use algebra to do some solving of equations. So that's where we're up to so far. As always, there's that WooTube site up here in the top right corner, wootube.mathspace.co. If you wanted to watch a teacher who's really quite enigmatic and exciting, talk about all these different particular subjects, then you can go in there and watch his videos as he's been teaching his class. Okay, now last week I left you with this challenge. They are pretty hard, and they're a little bit at sort of the top end of year 8, and that's okay. But using our rectangle method, we can actually almost do any sorts of expansion. It's just about finding that visual representation, and as I'm always saying, just do one step at a time. That's really important. So if you've done either of these challenges, then yeah, feel free to throw your answers in the chat there, and you can talk to Miss J. I'm just going to set up the rectangle so you can get a bit of a feel for it. So if you didn't know how to do it, you're going to have a starting point. You can go away and have a go. So here's our pen. So the challenge was to set these up using a rectangle. So you'll recall that the one number that's outside, we were just setting up on one of the side lengths. And then the expression inside the brackets, we were kind of calling like an expression of the length. So we could set that up. There's 3 terms there, so we would need 3 smaller rectangles where one side length is 6q, the next one is -2, and the next one is +3r. And so then that's it. That's the setting up of the rectangle. All that you've got left to do then is multiply and find the areas of all those smaller pieces. And that's just algebraic multiplication. So we have the first one is 2p times 6q. So when multiplying, I always do numbers first. So 2 times 6 is 12. And then because we're doing, because we're doing letters, you just, a multiplication, you just write the letters side by side. So it's 12pq. The next square, we have 2p times -2. So numbers first is 2 times 2 is 4. Different signs, so the sign is negative, and the letters that we have is a p. And then the last one is 2p times 3r. Numbers first, 2 times 3 is 6. And then because we're multiplying, we just write the letters side by side, we get PR. So when we write that all out, what we get is, the answer to this one is 12PQ minus 4P plus 6PR. Sounds like a Star Wars thing. 6PR, there we are. So that would be the expanded answer. If we weren't using the rectangle, you wanted to jump to it straight away, you would just multiply this 2p by each of those 3 terms inside, and you will get exactly the same answer. So there's 2 methods for the same question. This next one over here was a little bit more tricky. Because we had 2 expressions on each line, so this is really the extension piece. What we have here is, there's our starting rectangle. So if this was our first one, we have an expression, an a plus 2. It's like a length. So we've got 2 pieces on that side. We do the same at the bottom. We have a 3 plus b. And then we just need to find the areas of each of those smaller ones. So you just multiply them. This is a times 3, which is 3a. This is a times b, which we just write as ab. This is 2 times 3, which we write as 6. And this is 2 times b, which we write as 2b. So when you write them all out in one expression, you would get 3a plus ab plus 6 plus 2b. Now, if you got that, well done, because that is an extension. But it is just an extension of a physical model that we've been able to set up. So you'd be able to multiply and expand any sort of expression that had any number of terms in the first term and any number of terms in the second, as long as you just do it piece by piece, just one step at a time. Okay, so if you've just tuned in, that was just a challenge from last week. So if you're looking at that going, oh my goodness, where did all those letters come from? That's fine. We'd gone through quite a setup about this last week, and that is where I left the students for a little bit of homework to have a go with it. Okay, I'm just going to clear these out, clear that out, close that. Okay, on we go. So this is the Mathspace chapter. I'm going to be using a little bit of that this week. This is the chapter 4, section 405 on factorizing. So this is our Mathspace book. If you have access, then this is the section that we've been focusing on. If you haven't, that's fine. Every single Year 8 textbook will have a section on factorizing, and they'll cover the same concepts that we're doing, and they'll have a set of questions very similar to this for you to practice. So I just wanted to point out that I'm using this particular book, but every Year 8 book will have the same content. Okay, so where were we? This is what we were just doing last week, which was this idea about expansion. So like I mentioned at the very beginning, factorizing is the idea of going the other way. So firstly, let's remind ourselves about the expansion. Here's a very simple one, 2 groups of x plus 3. We can set that up using our rectangle. We have the 2 on one side and a length of x plus 3 on the other. And then the expansion is basically finding the area of the whole rectangle. So we find the area of the smaller pieces. So this would be 2x. Over here would be 6. And your whole expansion is 2x plus 6. The idea of factorizing is to go the other way. Okay, so let's start with this one. We've got a 10 plus 5a. So the idea is to go back the other way. So the 10 plus 5a, that is the areas. They're the bits inside. And what we want to do is find out a way to write the length and the width in a different way so that, you know, we'll put it into brackets if you like. And the way to do that is to think about common factors. So we're going to go through in detail how to do this today. But in this particular example, it would be, for example, a 5 in this particular length here and a 2 plus a. And you can see then 5 times 2 is 10 and 5 times a is 5a, and you get back to where we were. So we can go both directions. We can expand or we can factorize. And that's the focus of what we're doing today. Okay, so the skills that you should be pretty confident in before we try and do too much factorizing is you need to be pretty good at dividing. You need to be able to see 2 numbers and know a number that sort of goes into both. And we're going to just do a bit of a warm up on finding these sorts of common factors in a moment. You need to understand that a factor, which is that number that goes into something, it could be a number, but it could also be a letter. So if we go back to this one screen here, in this 5a, where we multiplied it to get 5a, I'll use my pen so you can see what I'm talking about. So this 5a here, that is what we call the product. And each of these, the 5 and the a, that you multiply to get the 5a, they're the factors. So in that particular expression, 5a, there's 2 factors, the 5 and the a, and the product, when you multiply them together, is 5a. If we had 2 other factors, like 2 and an a, we multiply them together, we would get 2a as the product. Now, the 2 products that we have here, these 2 terms, 5a and 2a, they have a common factor. A is a factor of both of them. And that's kind of the idea. We have done the same thing when we've done stuff about fractions. So for example, just clear that out. When we've looked at simplifying fractions, like to simplify the fraction 6/8, which we've been doing for a number of years by now, the way that we do that is to find common factors. We find a number that goes into both 6 and 8. What do you think that common factor could be? So we can look at what the factors of 6 and 8 are. I could write 6 as 2 times 3. I can write the 8 as 2 times 4. And then I can see that there's a common factor of 2. Remember, we've talked about this when we talked about multiplying and dividing of algebraic terms. If you have one thing, one term divided by the same, anything divided by itself is 1. That's what we call cancelling out. So in that case, 6/8 is the same as 3/4. So this idea of common factors is not new. We've been using it for quite a while, and we're just going to use it in a different context now. So that's kind of the things you need to be able to do. You need to be pretty good dividing, which means you should know your basic timetable facts or be able to recognise common factors. Okay, so we're going to do some your turns now. You'll have a little icon on the screen, and we're going to do a series of questions. I'm just going to read out 2 numbers. And I want you to drag your dot to which of these numbers do you think is the common factor between them. In fact, what I could do is I could write them on the screen for you. You may or may not see it depending on how you've set it up. So if we have the 2 numbers 3 and 6, and I said, which of the numbers on the screen is a common factor between 3 and 6? Drag your dot to where you think that is. Which of these is a common factor of 3 and 6? So just drag your dots in. Going to lock the screens. 3, 2, 1. So we're looking for a common factor between 3 and 6. We're looking for a number that goes into both 3 and 6. When we say sort of goes into, that's very casual language. What we mean is it divides evenly with no remainders, okay? So what we want to do is see if which of these numbers both 3 and 6 have in common. And in fact, the answer is 3. And most people have that answer there. It's very good. 3 is the correct answer because 3 goes into 3 one time and 3 goes into 6 2 times. Okay, so the next question is going to be a different one. So move all your dots off the 3. The next question is, what is the common factor between 12 and 10? So move your dots there. What is the common factor between 12 and 10? I'll write it up here in case you can see it. 12 and 10. What number goes into both 12 and 10? Not one of the numbers, both of the numbers. Yeah, so everyone's hovering over the 2. Fantastic. Both 12 and 10 are even numbers, so 2 is a good bet there. 12 is 2 times 6, and 10 is 2 times 5. So yes, 2 is indeed the common factor there. Well done. Okay, let's do another one. So move your dots off the 2. The next question is, what is the common factor between 24 and 32? What number goes into both 24 and 32? Now, there are a number of answers here. So don't be fooled. Don't just follow everyone else. There's actually a couple of answers. You're okay to pick one, but we'll talk about which ones are correct. So now, 8 is a factor of 24 and 32, but 8's not on our screen. So if you were thinking 8, that's absolutely fine. 8 does go into both of those. But they're both even. So 2 is definitely a common factor between all of those. So 2 is the correct answer. And 4 also goes into both of those numbers because 24 is 4 times 6. And 32 is 4 times what? 4. Yeah, so 4 goes into both. So 4 and 32 have a number of common factors. 2, 4, and 8. So any of those are common factors. The good thing about factorizing is it doesn't sort of matter which one you choose if there are multiples, because you might have to then just do it again. You just factorize again. That will be fine. Okay, clear that out. Let's do another one. Let's go. Common factor, please, between, and we'll do a hard one. I'll go jump to the bottom of my list because we're getting these right. 56 and 63. What do you reckon? Common factor. What number goes into both 56 and 63? If you had your little thing on a 2 there, 2 won't go into 63 because 63 is odd. So you'll need to move the 2. Yeah, so that's right, everybody. 7. 7 is the factor of 56 and 63 because 56 is 7/8 And 63 is 7 9. So 7 goes into both of them. Well done. Okay. We're really getting the hang of that. That's great. So I'm going to step it up a bit. On to the next slide. Okay, here we go. Same idea. You've got a little dot. We're going to look at now common factors, which will be letters. I've written the questions down the bottom, so we're going to do question 1 first. So what we want to do is, which of these letters is a common factor between the terms 2A and 3AB? So there's a letter that's common in both of those, and that's all you need to identify. Which of these letters is common? Okay, so I'm going to move on to the answers, give you a little moment. Okay, there we go. Yeah, fantastic, everyone. A is correct. So in 2A and 3AB, so remember 2A is 2 times A, and 3AB is 3 times A times B. So each of those little things are factors, and the common one is the letter A. Well done. Okay, question 2. Which of these letters is a common factor between AB and BC? So AB is A times B, BC is B times C. We're looking for things that are common, and in this case, yeah, you're right, everyone, B. That's what we want there. Okay, the last one is ABC and AC. ABC and AC. Now, like before, sometimes, like when we looked at the numbers, sometimes there are more than one possible answer. That can be true with letters as well. There can be more than one possible factor that is common. So you're looking for what is common between A, B, C and AC. Well, we've got A times B times C. We also have A times C. So in fact, A and C are common to both. So as long as you've got A or C, one of those two answers there, then that's the correct answer. So we can factorize. We can find common factors that are numbers, which are numeric. We can find common factors that are letters, which we call algebraic. And then we can find common factors that are both. So clear that out. We'll go on to the next one. We've got one more slide similar to this. Okay. Oh, that's the one we want. So which of these is a common factor between? So we're going to go through those options that are up the top there. So the first one is 3 and 3B. What is common between 3 and 3B? So over here, if we've got 3 and 3B, I'll just do it next to it actually. So 3 is just 3 times 1. There's no other factor of 3. 3 is prime. And then 3B is 3 times B. So out of those two statements, you're looking for something that's common. And as everyone's done there, we can see that the common thing is the number 3. So that has a numeric factor of 3. Okay, question 2. 4A and 6AB. So 4A and 6AB. There's a couple of options here. So 4A is 4 times A. And we could write a 4 as, say, 2 times 2 times A. So there's all the factors of 4A. On the other side, we have 6AB. So that's just a 6 times an A times a B. We could write 6 as 2 times 3, because it has 2 factors, times A times B. Then we want to find what's common. So there's a 2 that's common. There's an A that's common, which also means there's a 2A that's common. So the number of options there, we can have the number 2, we could factor out the letter A, or we could factor out the term 2A. All 3 are good answers there. So 2 is a factor, A is a factor, or we can take out 2A as a factor. All 3. Okay, question 3. So now we've talked about how you can have numeric, algebraic, or a combination of both. So question 3 is 8A and 16A. So 8A or 16A. So we want to think about what are the factors. Well, I can see here in 8A, I've got the factor 8 and A. I could write 8 as 2 times 4, And I could write that as 2 times 2 times 2 times a. That would all be fine. We could break that right down if we needed to. 16a, I can write as 16 times a. But 16 also has factors. I could write that as 2 times 8. And then, like before, I could write that 8 as 2 times 2 times 2. But what I can see here is that we've got some good common factors. 2 is definitely a common factor because they're both even. That would be fine. The a is a common factor, so a would be okay as an answer. 8a would also be a good answer because there's 8 in both, but also 2a is in both. There's a 2a there and a 2a there. So there's lots of common factors between those two. You just need to be able to sift it through one step at a time and keep seeing things that are common. So any of those answers that you've been hovering over are all good. Okay, last one is question 4. We've got 9ab and 12b. You're looking for common factors. So I can see instantly the algebraic common factor will be a b. So just having a b is fine. That would be absolutely correct. We want to check now, I've got our multiple choice options. We've got a couple of numbers, so I can see, firstly, does 3 go into both? Well, yes, 3 goes into 9 and into 12. So 3 could be a common factor. We're going to say b is good because b goes into both. We're going to say 3 is good because 3 goes into 9 3 times and 3 also goes into 12 4 times. 4 doesn't because 4 doesn't go into 9, so I'd leave the 4 out. We're not going to do a because there's no a in the 12b, so any of those terms with an a, no good. And that just leaves this last one of 3b. Well, if both 3 and b are common factors, then 3b is also a common factor. So any of those 3 is correct. Well done. Okay, so that's really the key thing here is being able to see common factors. And you can see now how linked division is to this. Like being able to do division and divide through and find common factors. And so not only do you need to see that it is what the factor is, but you need to know what's left over. So that's pretty key too. Okay, well done. Let's move on to the next slide. Okay, so once we get good at identifying those common factors like we've just been doing, then we can begin to factorize. Okay, so to factorize, we take the common factor out, which is the thing that's common, and we put that out the front of the brackets. So let's do some examples. So there are some good examples on our questions here. So I'm just going to pick a few to do because I like a few of these. So some of these are finding the common factor out the front of the brackets where it's sort of scaffolded and we sort of tell you a little bit. Some of these questions are about filling in the bits that are in the end of the brackets. And then some of them are factorized from the beginning. And that's, of course, where we want to be able to get to. So we'll do a few of those. And that's just exactly like we've been doing, finding the common factors between two terms. We need to be careful of our negatives and writing them in factorized form. So just going to move, got some windows in front of my screen here and I'll just zoom in a little bit. Okay, so this is a complete the factorization. So it's a little bit older, sort of giving you a little bit and you need to find the common factor out the front. Here is our expression, 3t plus 27. We want to find what number goes out the front of this. So for this next few steps, if you'd like to jump on the chat, that's fine. Renelle will be able to log your answers and give you some feedback as we're going. So certainly feel free to throw some answers into the chat. It'll also help me know that you're still engaged and you're having a go. So what we've got here is our expression 3t plus 27. You can see that here. And we're already telling you that the bit that we're taking out is t plus 9. That's what's left over. We want to know, well, what did we take out the front? What was the common factor that went out the front of this? Okay, so what did we have in this box so that when we multiplied it by t, we ended up with 3t? Remember, that's the process. When we were expanding, we would take that number and multiply it by that one. we would take the number and multiply it by the second. And when we do that multiplication, we get 3t plus 27. Yeah, so that's right, everybody. So the common factor there is just the number 3, because 3 is the common factor. And that's what we get with our factorization. Okay, there's another one exactly the same, except for there's a negative here. So we've got 3t minus 21. We know that whatever we have out the front, when we multiply it by t minus 7, we do this multiplying one by the other, we'll end up with 3t and minus 21. So what's that common factor there? So what do we multiply t by to get 3t? That's basically the answer. And so the answer is 3. Yeah, well done, everybody. That's great. Well, I'm really glad to see you throwing your answers in the chat. Okay, again, we're slightly scaffolded. I'm telling you the common factor, and now we need to see, well, what's left over? When we divide through each of those terms by the common factor, we'll have an expression, which means there's a plus or a minus or something left over in there, and we want to know what that is. So we've got the expression 5m plus 30. We know that we'll take 5 out. So basically, I need to divide each of these terms by the common factor of 5 and see what's left over. So if I have 5m and I divide through by 5, what do I have left over? Just the m. And that's because, remember, 5m is 5 times m. So when I divide by 5, I'm left with just m. Okay, 30. Well, we need to know what the factors of 30 are, and we want one of those factors to be a 5. So 30 could be written as 5 times 6. And when I divide through by 5, what I'm left with is 6. Yeah, well done. A lot of people got that right. That was fantastic. So we'll just go here, type it in just to check. M plus 6. Nice one. Okay, here we go. This one's got a negative. It's set up in a very similar way. So we've got 5b. Oops, 5b. Minus 35. So we're told we're taking out a factor of 5. We want to know what's left over. So in the same way we did it before, 5b is 5 times b. I'm told I'm dividing through by the common factor of 5. So what's left over is just the b. Now the next one is minus 35. So minus 35, we've got two things that multiply together to give us minus 35. We could have a minus 5 times 7, or minus 7 times 5. There's no other factors really. 35 and 1, that doesn't help us. We're told that one of the factors is 5. So I'm going to take out the positive 5. What does that leave me with? Minus 7. Okay. So see, most people, yeah, that's exactly right, Miss J. They're pretty quick, aren't they? It's great. So we put b minus 7 in there. Bingo. Okay. So now we're doing the full thing all on your own. You've got to factorize this. So you've got to find a common factor, put it out the front, find what's left over, fill in the brackets. So you can go off and do that. So yep, you can find the common factor first. So Fergus is right. He's found the common factor. I'm going to do it here. So we've got 4a plus 12. Okay, we want to find some common factors. So I can see, for example, that the number 2, because they're both even numbers. So I might go 2 is a common factor. So let's do that first. 2 is a common factor. 2 from 4a leaves me 2a, because 2 times 2a is 4a, and 2 out of 6 is 12. I could do that. I have in some sense factorized, but I haven't fully factorized. And I'll show you what I mean by that. If I type that answer in here, 2 bracket 2a plus 6, it'll say, yep, tick, but not finished. This happens a lot in mathematics. You need to fully simplify, fully factorize. You need to get it to the most simplest form possible. They are equivalent, they are the same, but you're not quite there. There's another step. And that's because there's another factor I can take out. So this is what I said to you before. It doesn't matter if you don't see the biggest common factor straight away. You've always got an opportunity to take out another factor. In this case, I can see, oh, well, they're both still even. So I can take out another 2, which actually meant at the beginning, I could have taken out a 4 straight up. And I know that a lot of you threw that in the chat already. That would be fine. So I'm going to do this first by taking another 2 out. So that would be the 2 I had plus taking out another 2 would leave me with a plus 3, which gives me 4a plus 3. That's fine. So if you don't quite take out all the factors straight up, that's okay. You can just keep going. You just factorize. And sometimes that happens when the terms are really complicated or when there's really big numbers. You sort of take a stab in the dark and you go, oh, I see 2's in there, or I can see I can take out an 8. And then later on you go, oh, I can also take out a 7. Who would have known 56 was a factor? Like, so you just need to do it step by step. So I'm going to do this one again. Do it down here, erase. I'm going to do it again, and this time just go straight from the 4a plus 12, because most people would have done that. So just do it one more time. 4a plus 12. The greatest common factor, the biggest number that goes into both of those is a 4. So if I take a 4 out of 4a, I'm left with a, because 4 times a, whoopsies, 4 times a is 4a, and I take out the common factor of 4, which leaves me with a. The value of 12 is 4 times 3, and when I take out the common factor of 4, I'm left with just the 3. Okay, so most people had that. Well done. I'll just enter that answer in. So the full factorization is 4a plus 3. Okay. Here's another one. It's got a negative in it. Looking for a common term, looking for a common factor, 24s and 15. What's the negative sign? 24s minus 15. Oopsies, I wrote a 12 instead of the 5. That's why you've got to always check your work. Okay, there we are, 24s minus 15. So we're looking for something that goes into both of those things. So 24s I could write as 24 times s. Well, what factors of 24 are there? Well, there's 3 times 8. Let's just try that. 15, I've got 3 times 5 times s. So no s. Oh, I'm making up stuff today. Good thing some people around here keeping me honest. Okay, so what are our common factors? So I can see the 3 is common. So that's going to be my outside the brackets. And then I can see easily what's left here is 8s and see what's left here. And then it's going to be a negative because there's a negative 15. It's negative 5. Those negatives are really tricky. It's really tricky. I don't want to teach you a rule. I don't want to teach you, steps and try and lock you into a process. You really just need to feel negatives and know that in this case, a positive times a negative would give me the negative 15. If both numbers were positive, like this is positive here, this is positive, and this is positive, then 2 positives gives me the positive. So really feel your way through those negatives. If there's a negative in the question, always check your answer. That's the great thing about questions, is you can always expand and check. There's no excuse for getting them wrong in any test, because if you've got time, you can always expand your answer. So if we think this is our answer, 3 times 8s minus 5, we check it. 3 times 8s, 24s. 3 times negative 5, negative 15. Like, you just know you're right. So that's what's great about these questions. So let's put that in. 3 bracket 8s minus 5. There we go. Okay. So that's sort of some fairly basic common factors that are going on. We've looked at taking out numeric factors mostly. So let's have a look now, finding somewhere there are algebraic factors. So we're going to scroll down. Actually, I'll do this one. This is a numeric one, but there's some negatives in there, and we've just looked at how negatives are important to have a look at. let's do this one. We're getting pretty complicated. There's lots of letters and numbers down here. Oh, that's a good one. Let's try that. Okay, a few more. Oh, I better check my time. Yeah, we're doing well. Okay. Just looked at the time and I've gone, hang on a minute, are we doing well? Let me check. Oh, I've got some for you to do. Let's do that. Let's go to your turn. Much better for you to do it. You've been getting them right in the chat, so let's go straight in. We won't spend too long on each slide. There's a couple of slides here. So let's have a look at factorising 12a minus 6b. If you haven't used this one before, you basically show you're working in the slide and then you throw your final answer in the yellow box. I will show that because everyone's got their own little animal, I can put the answers up on the board and I'll be able to see what people are up to. Who's this one? Oh, it's not showing us the animals. Okay, do it on mine. Just going to turn to the side so I can see the animals and see the see responses on my dashboard. So when I look to the side, that's all I'm looking at. What have we got going on? It's 12a minus 6b. So what we're looking for are common factors between the two. I'm going to skip through this one. I think we should be getting them. Common factor between 12a and 6b is 6. And I take a 6 out of 12a. So 12a was 12 times a, which was 6 times 2 times a. I take the 6 out, leaves me with 2a. And I can check it. 6 times 2a is 12a. I know that's right. If I take a 6 out of minus 6b, I'm going to have a minus b left over. So that's what you're looking for, is 6 brackets 2a minus b. Okay, clear that out. Let's do the next one. It's another your turn. Minus 3, oh, this is negatives. Make sure you're watching them. Minus 3 minus 6ab. So you want to find common factors between minus 3 and minus 6ab. You should notice pretty quickly that the common factor there is minus 3. But if you just chose a 3, that's okay. You'll have negatives left over at the end. So minus 3 is minus 3 times 1. Minus 6ab is minus 6 times a times b, which is minus 2 times 3 times a times b. That's just all the factors, just writing them out, trying to find common ones. Where is the common factors? Minus 3 leaves me with a 1. Take out the minus 3, leaves me with a 2ab. Now the negatives are really tricky. If you hadn't taken out negative 3, if you'd just taken out a positive 3, that's okay. You'd have ended up with a minus 1, minus 2ab inside. And, you know, the truth is there's actually no consensus in the mathematical community about which one is more simplified. Sometimes it makes sense to take the negative out. It turns these two positive. Sometimes you want the outside one to be positive, so you leave the negatives inside. So it does mathematically, they're both the same. Just make sure you double check with your teacher if they think that the negative should be taken out. You don't want to lose a little mark because it's, you know, each sort of particular teacher thinks something different. If the whole mathematical community can't agree in the world, then it's likely there are teachers that have different opinions. So I'm happy with either of those, absolutely. Okay, let's keep going because you guys are doing well. That was tricky with the negatives. Wow, have a look at that. So have a go, but if you're a bit stuck, let me just point this out. The term w squared is one term of w times w that is common to both. So in terms of algebraic factors, w squared is common. So we could take the w squared out. That would be fine. But you can take the whole thing. There are some cases where we might just take one w's, but generally speaking, we wouldn't do that until next year. Yeah, some people doing really well on that. So then once you've identified the algebraic factor, you also need to identify if there are any numeric factors. Is there a number that goes into both 21 and 35? So if you're thinking things out, doing one step at a time, you might do something like this. 21 is 7 times 3. I've already taken the w squared out. Over here we've got 35 w squared z. So 35 is 7 times 5. That's why it's really important that you know your times tables. The w squared we've already done. Looking for other common factors, I can see 7. So I'm going to take that out the front. That leaves me with just a 3 in the first term. And I can check that because 3 times 7 is 21 w squared. What's left over here? I've got a 5 and a z. That's what we're looking for. 3 plus 5z. Yeah, it's fine. So it doesn't matter if you didn't do the whole thing at once. If you just did the w squared to begin with, which is, let me show you that one. If you just did the w squared first, then you would just have 21 plus 35z left. Now, that's not fully factorized yet because there is still another common factor. But at least that's the first step. That would just be your first step and you can start with that. The next thing is then to recognize that 21 and 35 have a common factor. So you would then go, oh, 7, and you could take the 7 out next. So that would absolutely be a very legitimate first step, but it isn't finished. So some of you stopped there, which is fine, but it's not quite finished. Make sure you go to the next step. Oh, okay. Who's up for a challenge? This is our last one of the day. Got time? Just enough time. All right, let's have a quick look. Just like when we were doing the challenge with the expansions, it doesn't matter how many terms there are, as long as you do the same factor for each term. So you just need to identify common factors, but instead of finding common factors between 2 things, we're now finding common factors with 3. So I'm just going to write out my 3 terms, 6a, 12ab, and 4ac. And I'm going to try and find common factors. So this is 6 times a. 6 I could write as 2 times 3. Okay, 12ab, well that's 2 times 6 times a times b. And I know I can write 6 as 2 times 3. So just finding common factors. 4ac is 4 times a times c. I could write 4 as 2 times 2. Now, if you're good at being able to identify factors just by looking at them and going, oh, I can see 2 goes into all of those. I can see 2a, then you don't need to do this step. But there are some people who just when they're learning need to practice seeing the common factors. So what we have here is what's common. An a. And then looking at the numbers, there's a 2 in each. 2, 2, 2. So that means our common factor is 2a. And then I take out the brackets, what's left over? I've taken out a 2a, I've got a 3 in the first term. I've taken out a 2a, which gives me a minus 2 times 3 is 6b. Left over. See here, 2 times 3 is 6 and the b. And remember I said always be careful of your negatives. I've taken out the 2a from this last term, which leaves me with 2c. That was a tricky one. That is probably one of the hardest ones that you do at this level. So it is in our challenge sort of section. It's at that top end. And only because there were 3 terms and you had to find one factor that went into all 3. Not because the factor or finding that factor of 2a was any more difficult. So really just make sure you're watching for those individual common factors. Okay, you guys have been fantastic today. So basically, when we're wrapping up algebra, let's go over the whole chapter. These are the things that you need to, this is like a checklist, okay? Can you do these things? And if you can, then you're well placed to move forward. Next week when we do equations, we're going to use these algebraic skills. So can you identify like terms? Can you add and subtract algebraic terms? And to do that, you need to remember you can only add and subtract like terms. Can you multiply and divide algebraic terms? Do you remember that multiplying, you just sort of squish them all together? Do you remember that when you're dividing, you're sort of cancelling out that idea that anything divided by itself is 1? Can you expand brackets? We did that last week using the distributive law or that rectangle idea. And can you go the other way and factorize things, put them into brackets? And then the last thing is, if I told you what the value of any of those letters were, could you evaluate them? And that is our key concepts from all of algebra. So use that as a bit of a checklist. If you're a bit stuck on any of those things, you need to go to last week's video for expansion, the week before's video for the first 3 dot points. Your year 8 textbook will have it all, and you're going back to school soon, so you might be able to go, oh, I'm just a bit stuck. You know, you could ask your teacher, I'm just a bit stuck on multiplying and dividing algebraic terms, and they would love to help you on that. So that's basically the end of algebra. Really glad that you've all joined us today and you've stuck with us. It's fantastic. Our class size was a bit smaller today, so clearly some kids have gone back to school. But yeah, it's been great having you again. If you've got any questions in QA, I'm happy to stick around and answer them. Nothing there at the moment, Miss J? Okay.
Nothing.
Fantastic. Well, that's it for today, everybody. Thanks heaps. Yeah, go away, practice your expansion and factorizing, and we'll come back next week and I'll see you for equations. If I don't see you in person, won't be offended. I'll know you're going to watch the video.
Bye, everybody.
Bye,
Have
everyone.
a great rest of your day.